Hi, welcome to the video for Edexcel Physics Past Paper Solution. It is Unit 3 IAL Physics, January 2017. So let's start. Question number 1. Which of the following is an SI base unit? So it's all about base unit, and it is a typical question regarding unit that just keep coming in a different paper. So in my suggestion, if you can memorize about the base unit, and there are 7 base unit. If you can memorize, it will be good and a lot of help for you. These are meter, kilogram and second, Kelvin, ampere, mole and candela. So 1, 2, 3, 4, 5, 6 and 7. These are 7 base unit, and their corresponding quantities are: meter is for length, kilogram is for mass, S is for time, K is for temperature, A is for current, mole is for amount of substance, and CD is candela. This is light intensity. So if you light intensity, so if you memorize this list, so these are 7 units which are base, and these are 7 base quantities, and other than these all are SI derived quantities. So you need to select SI base unit, and force and Newton are not in these list of unit and the quantities. Second and time both are in the list, but remember, second is the unit and time is the quantity, and they are talking about SI base units. That's why your option is C. Question number 2. A student records the following times in an experiment. So these are the data set. Which of the following should be stated as the mean value of the time with a suitable uncertainty? Okay, so again a typical question of Unit 3. Generally, not always, but generally, they want to check your anomalous recognition, the concept of whether you can check or whether you can see the anomalous reading in the data set, and they want you to delete it and consider rest of the uh, data set value in your calculation. So this is 0.71, 0.69, 0.70, 0.59. Clearly, this is your anomalous reading, so you need to discard this value for your calculation. And the mean value is the mean of all rest of the 3, and then we talk about the uncertainty. So first you find the mean of these value. So finding mean means you add these 3, 0.71 plus 0.69 plus 0.70 divided by 3, and the mean of these 3 numbers would be, of course, 0.70. And now you need to see what uncertainty you should write here. So uncertainty we find range divided by 2. So range is highest value minus lowest value. So if you do your calculation, so 0.71 minus 0.69 divided by 2, and it will give you value 0.01. So this is your uncertainty. So you must write 0.70 plus minus 0.01 Yes, so B. This B is your option. Question number 3, 4, and 5 refers to an experiment to determine the Young modulus for the material of a wire. To determine the Young modulus of the material, which of the following is not needed? Okay, so density, extension, applied force, and the original length. Because we need to find the Young modulus, then Young modulus is stress over strain, and then stress is force per unit area, and then strain is change in length per unit length. And clearly you can see that you need extension, you need it, force applied, this is the force, you need force, original length, you also need original length, so this is also you need in your Young modulus calculation. The only thing that you don't need is the density of the material, so your option is A. Question number 4, which of the following instruments should be used to measure the diameter of the wire? Again, in the Young modulus, or even if they talk about resistivity and any kind of these material, a thin material, and if you need to find the diameter, generally we use micrometer screw gauge. So C is your option. Question number 5, which of the following is the correct unit for the Young modulus? As you can see that the Young modulus is the ratio between stress over strain, and stress is force per unit area, which is Pascal, and strain has no unit. That means the Young modulus has a unit only Pascal. Option is C. Question number 6. A student has been asked to determine the center of gravity of the cricket bat, like the one shown. Describe a simple method to determine the center of gravity of the cricket bat. A simple method to determine the center of gravity is we need to balance the given object, in this case the bat, on some sharp edge or knife. Generally it is a pivot. So we try to balance the bat on some pivot. Once it is balanced, then we measure the distance from any one of the end, and this distance shows the position of the center of gravity of the bat. So balancing on the edge, after balancing measure the distance, and then it will show the position of the center of gravity. That's how you can reframe your answer. Explain the physics of your method and any assumption you have made. Assumption that we are making in our method is that the center of gravity is the point where the weight of the bat is acting, and the physics that we are using after balancing the clockwise movement is equal to the anti-clockwise movement. So this is clockwise movement and this is anti-clockwise movement. If both moments are equal, then the object will be in equilibrium. This is the principle behind the calculation. Question number 7. A student is asked to determine the speed of the sound in air. The apparatus to do this include two microphones connected to an oscilloscope as shown. Dual beam oscilloscope, long leads, microphone and microphone. Okay. The student will make a noise near one of the microphones. The oscilloscope can display the signals from both microphones as traces on the same screen. The student will observe the difference between the two stationary traces. Okay, idea behind this experiment is we have a two microphone, and this is the oscilloscope in which you clearly see the traces of the two sounds. Why do we have a two traces? Because if suppose we make sound at this position, okay, then sound wave travel toward this microphone and goes, and this shows as a signal. Let's say we can suppose this is the lower one, then the sound travel toward the second microphone, sorry, and then it displays the second note or second display. So this is a display about the two sounds coming from each microphone. Okay, so remember, sound produced and the sound waves travel towards the microphone, enter into the oscilloscope, so we have two different traces. Okay. Write a plan for this experiment. You should outline the experimental procedure. Okay. So experimental procedure. So it's all about measuring the sound, and as you can see in a previous diagram, we need to measure the distance between the two microphones and the distance between the peaks of the traces, and from which we can measure the time. And also we need some, yes, of course, so we measure the distance and the time between the two peaks, and we can use this distance and the time to find the speed of sound. List any additional apparatus required not shown in the diagram. Yes, we need a meter rule to measure the distance traveled by the sound between the microphone, and we need some source that can produce a sound wave. So mainly two things: a meter rule to measure the distance and some source to produce sound. State the quantities to be measured. Identify the independent and dependent variable. The independent variable is the distance between the source and the microphone, and the dependent variable is the time between the two peaks. Okay. Comment on whether repeat readings are appropriate. Yes, of course, in this experiment, repeat reading should be appropriate, so we can use the mean to reduce random error or any error that we can have. So repeat reading is of course appropriate. State how the data collected will be used to determine the speed of the sound. So the straightforward method is we can use the measured distance and the time between the two peaks, and we can use these two in the formula uh, v is equal to distance upon time to calculate the velocity of the sound. Identify the main sources of uncertainty and or a systematic error, and explain how you would minimize these. Okay. Main source of uncertainty is the time between the two peaks, because the time interval between the peak is very short interval, so there is a large chances of uncertainty. So what can we do to reduce this uncertainty? We can increase the distance between the two microphones, and we can find the differences between the distances of each microphone. So we can reduce the uncertainty, and we can increase the time interval between the peaks. Comment on safety. This experiment involves producing of sound, and of course we are not producing loud sound, so there is no risk or no hazards regarding producing of sound, like damaging eardrum or maybe even noise pollution, these kinds of stuff, especially damaging eardrum in these kind of experiment. But we are producing low noise, so it's fine, there's no risk. Question number 8. A student investigates the resistance of a circuit component at a different potential differences. Her results are shown in the table. So this is the potential difference across a component, and the current, okay, 0.51, okay, 0.12, okay. Criticize her result. Again, a typical question comes in unit 3, criticizing the result. And of course the one is the less number of reading are there, significant figures, okay, this is 2, this is 1, again 1, so um, significant figures are the problem, and less number of reading, a small range, yes, you can say that from 0 to 2.5 the student could go above 2.5, maybe 3 to 6 or till 9 volts, so it is a low range. Repetition is not showing. These are some drawback in this reading. Plot the graph of V on the y-axis against I on the y-axis on the grid opposite, and draw a line of best fit. Okay, so these are the values, and this is the graph. So you need to select V on the x-axis and I on the y-axis. So you must choose the scale so that you can use more than 50%. Please be careful. You must use more than 50% region of the graph. So you choose scale wisely, and then you can plot the graph and the line of best fit. So that's how you can choose the scale. So this is the voltage. Don't forget to mark V with the unit V. And the current given in milliampere. If you don't write these units, you will lose your marks. So must write the units. And appropriate scale to show a large region of the graph. And then you can plot the corresponding values. So at 0 you have a 0, for 0.5 you have a 0, 1 you have a 12, 1.5. So you can plot these points like these. So 0 with the 0, again 0.5 with the 0, 1 and 12, 1.5 and 30, 2 and 52, 2.5 and around 78. And then you plot the best fit. So this is the best fit line that you can plot. Because I'm just drawing on computer, so please just ignore this. You must go straight from there. Okay, so part C is use your graph to determine the resistance at 40 milliampere. If you see, this is the 40 line, the corresponding value of V somewhere here. Okay, so that means at 40 you have a current around 1 point, okay, 2, 4, and then, okay, yes, it is around 1.7172. Okay, I'll just in between, I guess. Yes, so 1.75, so I'm choosing it 1.75. So you can see that the I is 40 milliampere, and corresponding value of V is 1.75. You can use even 7.2. It's up to you. It depends on the best fit. And then V. So resistance is equal to 1.75 divided by 40 into 10 to the power minus 3. Please don't forget to write 10 to the power minus 3. So when you solve this, you have R is equal to 43.8 ohm. This is the resistance at 40 milliampere. With reference to the resistance of the component, explain the shape of the graph between 0 to 0.5. If you see between 0 to 0.5, voltage is increasing, but current remains same. Current is 0. Not, yeah, it's same, but current, important point, the current is 0. So you can say that the resistance of the component is very high. That's why initially increasing voltage does not cause the current to flow. So you can say that between this interval, the resistance of the component is very high, so increasing voltage, but current is not increasing. In fact, this is a graph of diode. So if you see in diode, this is the voltage and this is the current. So initially, if you keep increasing the voltage, current does not increase, but after some critical value of voltage, current rapidly increase. So this is the behavior of diode. In fact, the component was diode. That's it for this paper. Thank you very much. Have a nice time.